Okay, for the second function, f of theta, sine theta times cosine theta, we are being asked to find the possible points of inflection of f of theta. So to do this, we need to uh, solve for the second derivative of f of theta. I have already prepared the computation of f double prime of theta. So it is equal to -4 cosine theta sine theta. And therefore, we find the possible points of inflection of f to be the zeros of f double prime of theta. But the zeros of f double prime of theta are exactly given by the zeros of cosine theta and sine theta. So if this is your unit circle, the angle made by theta or the zeros of the cosine and sine theta are exactly uh, the terminal angles by that coincides with the red points. And so, and also we should remember that the cosine and sine functions are periodic with period 2 pi. Okay, so the zeros are given by 2, 2n pi, 2n pi plus pi over 2, 2n pi plus pi, and 2n pi plus 3 pi over 2 for all n in Z, or the set of integers. Okay, so if we want to construct a table of signs for f, we can do it like so. So theta should be 2n pi plus 0 pi over 2 pi 3 pi over 2. Okay. If f double prime of theta is in between 2n pi plus 0 and 2n pi plus pi over 2, so that's around this quadrant, or in the first quadrant. Okay, so the sine function is positive in this quadrant, and the cosine function is positive in this quadrant. And therefore, f double prime of theta is negative in this quadrant. So similarly, in the second quadrant, which is 2n pi plus pi over 2 up until 2n pi plus pi in the second quadrant. So sine is positive in that quadrant, while cosine is negative in that quadrant. So that's positive times negative times negative. F double prime is positive. And in this quadrant, in the third quadrant, cosine is negative, sine is negative. So f double prime of theta is negative. Okay. So in the first quadrant, so that's 2n pi plus 3 pi over 2 up until 2n pi plus 2 pi. This is the fourth quadrant. The cosine function is negative while the sine function is positive. Is also okay. I mean, the cosine function is positive in this in the fourth quadrant, while the sine function is negative. So f double prime of theta should be positive in this quadrant. Okay, as we can see, whenever theta passes through 2n pi plus 0 or pi over 2 or pi or 3 pi over 2, the sign of f double prime of theta changes. Therefore, all of them are actual points of inflection of f. So the points of inflection of f are theta equals 2n pi plus 0 or pi over 2 or 3 pi over 2. Okay, that's it. Or if you want a more succinct answer, we can actually write this as theta equals n pi or n pi plus pi over 2 for all n in J. And from that table of signs, we also see that f is concave up when when theta is in 2n pi to it's concave up from 2n pi plus 2n pi plus pi over 2 up until 2n pi plus pi. So from this, and it's also concave up from 2n pi plus 3 pi over 2 up until 2n pi plus 2 pi. Okay, this is the fourth quadrant from this. F is also concave down when theta is in 2n pi to 2n pi plus pi over 2 and 2n pi plus pi to 2n pi plus 3 pi over 2. Okay. So just to make this clearer, this interval is the fourth quadrant. This interval, this interval is the second quadrant, and this interval is the fourth quadrant. This interval is the first quadrant, and this interval is the third quadrant. Okay, so I'll see you in the next video.